Hello, hi everyone. Welcome to the Student in the Brand. This is our Shiva sir. Today we are going to discuss about today we are going to discuss about light reflection and refraction. So I am the newspaper. Today theme is newspaper. So I am the newspaper. So I am teaching the concept. Okay. So light reflection and refraction. Light reflection and refraction. Today we will discuss about it. Here I am taking like this. Light is a form of energy which gives the sensation of sight. Light is a form of energy, so which gives the sensation of sight. So I'm considering here light reflection and refraction. Light reflection, light reflection and refraction, and refraction. Okay. So I'm taking the plane mirror. This is a plane mirror. This is a plane mirror. When light incident on it, it will reflect back. The light incident on it reflect back. Okay. So the light ray which is incidenting on it, that is incident ray. So I am taking this incident ray. And here this is a reflected ray. Incident ray, reflected ray, reflected ray, reflected ray, and the line which is perpendicular to the plane surface, that is called normal line. So here you can observe this is a normal line. So this is undeviated line. Undeviated line. Once again, so incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. So here you can observe incident ray, reflected ray, normal line. So the light ray which is incidenting on it, incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection. Okay, so this is the angle of incidence, and this one is the angle of reflection, and this one is the angle of deviation. Angle of deviation. Okay, so now you can observe here. Okay, so incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Okay, so here you can observe this incident ray, reflected ray, normal line, and this is the normal line. Normal line. So the angle between reflected ray and undeviated line. This dotted line is undeviated line. This dotted line is undeviated line. So this angle is called angle of deviation. Coming to loss of reflection. Loss of reflection. Loss of reflection. Okay, loss of reflection. First one, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Point number 1. Incident ray, reflected ray, normal line lies on the same plane and angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. So this is about loss of reflection. Once again, incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Coming to loss of reflection, incident ray, reflected ray, normal line lies on the plane, lies on the same plane. Angle of incident is equal to angle of reflection. Okay. So next one we will discuss about regular reflection or irregular reflection. Regular reflection and irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. So here I am taking like this plane mirror. So incident light rays. So here you can observe incident light rays are parallel to each other. Incident light rays are parallel. Okay. Then reflector light rays are also parallel to each other. Incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection. So here I am taking like this irregular reflection. So here you can observe incident light rays are parallel, then reflector light rays are also parallel to each other. The incident light rays are parallel, then reflector light rays are also parallel to each other. The type of reflection is called regular reflection. Coming to regular reflection, incident light rays are parallel but reflector light rays are not parallel to each other. Incident light rays are parallel but reflector light rays are not parallel to each other. So this is called regular reflection. Regular reflection. And this one is irregular reflection. Irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Next one. Object and image. So now we will discuss about object and image. Real object and virtual image. Real object and virtual image. Okay. Real image and virtual object. Here you can observe in this. So light rays are coming from this object. Light rays are coming from this point. Okay, so incident light rays, these are the incident light rays. So after reflection, those are moving away from it. Here we are extending the reflector light ray. This one reflector light ray, this one reflector light ray. So we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their virtual image is forming. Here you can observe the incident light ray after reflection. Those are meeting at one point. So this is the real image. So we are extending the incident light rays. Extended incident light rays are meeting at one point. Their virtual object. So if you observe these two diagrams, we can conclude that. If you observe these two diagrams, we can conclude that object is real, image is virtual, image is real, object is virtual. Right? Yes. Object is real, image is virtual. Object is virtual, image is real. Okay, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So by concluding these two diagrams, okay, so real object and virtual image, real image and virtual object, real object and virtual image, real image and virtual object. Okay, so here you can observe the point of intersection of incident light rays is called real object. The point of intersection of reflector light rays is called virtual image. The point of intersection of reflector light rays, directly reflector light rays are meeting here. Directly reflector light rays are meeting here. That's why it is real image. Here we are extending the incident light rays. Extended incident light rays are meeting at one point. They are virtual object. By observing these two diagrams, we can conclude that object is real, image is virtual, object is virtual, image is real. Okay. So this is about object and image. And next one we will discuss about one more. Nature of the image formed by the plane mirror. We will discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. Nature of the image. So I am taking the plane mirror. This is the plane mirror. So this is the object. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So I am taking here one light ray. So after that one more light ray. So like this. Okay. Now so this is the object. This is the object. Yes, it is a plane mirror. So this is the object AB. So we are extending the light rays. Okay, so this reflector light rays and this reflector light rays are meeting here. So A dash and B dash, A dash and B dash. Okay. Now, so as I said, as we discussed in the previous examples, if object is real, image is virtual. If the object is real, image is virtual. If object is virtual, image is real. Okay. So now object, first one is object is real. Object is real, image is virtual. Object is virtual, image is real. Point number one. Coming to point number two, the object distance, the distance between object to mirror. This is the object and this is the mirror. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Image distance. So image distance can be denoted with V. Object distance can be denoted with U. So object distance is equal to image distance. Object distance is equal to image distance. And also magnification. Magnification is +1. Magnification is +1. That is nothing but height of the object is equal to height of the image. Height of the image by height of the object, magnification. Okay. So here height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay. So magnification will get +1. Sir, why you are getting magnification is +1? Because so we are getting here what type of image is forming virtual erect and same size. Virtual erect and same size. Yes, correct. So distance between object to mirror is equal to distance between mirror to image is same. So that's why object distance is equal to image distance. And also magnification is +1. So magnification is nothing but height of the image by height of the object. So what type of image we are getting? Virtual image. Virtual image and same size. Virtual image and same size. That's why we are taking here height of the image equal to height of the object. Height of the image equal to height of the object. And also fifth one, it shows the lateral inversion. It shows lateral inversion. So what is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Lateral inversion. Lateral inversion. Sir, what is meaning of lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So if you stand in front of the mirror, if you lift your right hand, it appears in the left side of the mirror. Okay, so in the image. So if you lift your left hand, so object, it appears in the right side of the image. So this mirror image is called lateral inversion. So what is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of this mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear. So this is about a plane mirror. Okay, next one. So we will discuss about one more. That is about spherical mirrors. We'll discuss. Yeah, of course, definitely. So we will discuss about concave and convex mirror also. Now we are so discussing about spherical mirrors. Yes, spherical mirrors, spherical mirrors. So I am taking the concave mirror, like some portion I am taking in the mirror. The mirror which in the form of curved surface is called spherical mirror. The mirror which is in the form of curved surface is called spherical mirror. The mirror which in the form of curved surface is called spherical mirror. Depending on reflection of light, spherical mirrors are divided. Spherical mirrors are divided into two types. One is concave mirror, and one is convex mirror. So now we will discuss about concave mirror. So actually, we don't have these points. So we revealed the big breaking news in before only. So this is the twist. So in part 2 we'll discuss. Now we are discussing about spherical mirrors. So the mirror which in the form of curved surface, that is called spherical mirror. Concave mirror is also known as converging mirror. Concave mirror, converging mirror, convex mirror, diverging mirror. Concave mirror, converging mirror, convex mirror, diverging mirror. Convex mirror, diverging mirror. So concave mirror is also called converging mirror. So why you are calling concave mirror is called concave mirror is a converging mirror and convex mirror is a diverging mirror. So what is the meaning of that? Why we are calling? Because when light rays are incidentally on it, after reflection, light rays are moving towards the principal axis. After reflection, light rays are moving towards the principal axis. Here, after reflection, light rays are moving away from the principal axis. That's why concave mirror is called converging mirror. That's why convex mirror is called diverging mirror. Concave mirror is converging mirror. Convex mirror, diverging mirror. So here they will ask about show the converging nature and diverging nature. Means you have to draw these two diagrams, converging Concave mirror converging whenever light rays incident after reflection. The light rays are moving towards the principal axis, and coming to convex mirror, after reflection, light rays are moving away from the principal axis. Concave mirror and convex mirror, both you have to draw the nature of the image, means you have to draw these two diagrams. After that, we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Breaking news. Without breaking, I will explain the breaking news. Listen carefully here. I am considering concave mirror. Concave mirror. The midpoint of the mirror is called pole. So actually, it is a part of the sphere. It is a part of the sphere. The center of the imaginary sphere in which mirror is a part is called center of curvature. Center of curvature. The midpoint of the mirror is called pole. After reflection, all light rays will meet at one point on the principal axis. Is called focus. After reflection, all light rays will meet at one point on the principal axis called principal focus, or simply we can say focus. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Radius of curvature. The distance between focus to pole is called focal length. Focal length. Everybody listen here. Eyes on concave mirror. Eyes on concave mirror. Everybody. Eyes on concave mirror. Okay. So here you can observe the center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. The distance between center of curvature and pole is called radius of curvature. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called aperture. The line joining of center of curvature and pole is called. The line joining of center of curvature and pole is called principal axis. Principal axis. The center of the imaginary sphere in which mirror is a part is called center of curvature. Center of the imaginary sphere in which mirror is a part is called center of curvature. So see, first point is C, second point is pole, third point is principal axis, principal axis, principal axis, and coming to the fourth one is radius of curvature, fifth one is focus, sixth one is focal length, seventh one is aperture. Aperture. Once again, the center of the imaginary sphere. So today theme is newspaper. Today theme is newspaper. I'm a newspaper, so I'm teaching physics. So like that is the theme. So here the center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. The principal line joining of center curvature and pole is called principal axis. The distance between center curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length. Okay, and the width of the mirror is called aperture. Width of the mirror is called aperture. I hope it is very clear. Yes. Now we are going to discuss about one more. So ray rules, ray rules, ray rules, ray rules, ray rules, ray rules, ray rules of concave mirror and convex mirror. Ray rules of concave mirror. So now we are discussing about ray rules. Ready for it? Ready for the war? So concave mirror. So this is the pole, focus, center of curvature. Light ray is coming from infinity. Light ray is coming from infinity. So after reflection, it passes through focus. First one is light ray is coming from infinity. After reflection, passes through focus. The second one is pole, focus, center of curvature. Light ray is passing through focus. After reflection, moves towards infinity. And coming to the third one, pole, focus, center of curvature. Light ray is passing through center of curvature. After reflection, it retraces its original path. So 1, 2, 3. Coming to the fourth one. So light rays are incidenting on it. So pole, focus, center of curvature, light rays incident in the pole, it reflect back. So this is about concave mirror. And coming to the convex mirror. Convex mirror. So coming to the convex mirror. Okay. First point. So pole, focus, center of curvature, light rays. Sorry, this is concave mirror. Now we have to discuss about convex mirror, no? So pole, focus, center of curvature, light rays coming from infinity after reflection. Point number 1. Passes through focus. So coming to second one. Okay, so check here once. This is a concave mirror and convex mirror. Light ray is coming from infinity after reflection passes through focus. Light ray is passing through focus after reflection moves towards infinity. Here light ray is passing through center of curvature. It retraces its original path. Here light ray is incidenting a pole. It reflects back. Here light ray is coming from infinity after reflection passes through focus. Light ray is passing through focus after reflection moves towards infinity. Here light ray is passing through center of curvature. It retraces its original path. Here light ray is incidenting at the pole. It reflects back. So this is about concave mirror and convex mirror ray rules. Now we will discuss about image formations. Now image formations, be ready. So now we will discuss about image formations. Image formations of concave mirror and convex mirror. Concave mirror image formations. So first, so I'm taking the concave mirror like this. So pole, focus, central curvature. Pole, focus, central curvature. Light rays coming from infinity. After reflection, those are meeting at focus. Object is at infinity, image is forming at F. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. So pole, focus, central curvature. So object is placed beyond central curvature. Object is placed beyond central curvature. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. So after that passes through focus. Another light ray passing through central curvature. So the image will form between C and F. So object is placed beyond C. Beyond C, image is forming between C and F. Nature of the image is real and inverted, and the size of the image is diminished. Compared to the object, image size is decreased. Coming to third one. So pole, focus, central curvature. Object is placed at C. So how many light rays are required to form the image of the object? Minimum 2 light rays are required. So minimum 2 light rays are required, right? So that's why I'm taking here. So object is placed at C, image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Okay. So coming to the fourth one. Object is placed between C and F. One light ray I am taking like this, it passes through focus. Another light ray incidenting at the pole, it reflects back. Object is placed between F and P. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. So these are the 4 diagrams. Next object is placed at F. So after that we'll discuss one more. Okay. So be ready. La 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 la. Na 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 na. La 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 la. last second one. Object is placed at F. Object is placed at F. Image will form at infinity. Object is placed at F. So pole, focus, center of curvature. Object is placed at F. One light I am taking like this. It passes through like this. Another light incidentting at the pole. It reflects back. Object is at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So that is the fifth one. Okay. So fifth one. Coming to sixth one. So very important sixth one. 3 marks question for board exam. So even nature of the image, position of the image and applications. Okay, applications are very important. So make sure that you are practicing twice or thrice because that much important it is. So this is the pole, focus, center of curvature, object is placed between F and P. One lighter I am taking like this, another lighter is passes through like this. So if you are extending the reflector lighter, the image will form here. Very important condition, very important case. Okay, so definitely. So definitely here this condition is very important expected for exam. Okay, so make sure that you are okay. So practicing this one. Object is placed between F and P. Image will form behind the mirror. Behind the mirror. Nature of the image is real and virtual erect. Actually, yes, Tanmay. I got it. So object is placed between F and P. Image is formed behind the mirror. Nature of the image is virtual erect and enlarged. Virtual erect and enlarged. So very important. Hi everybody. Hi Dhananjay. Hi to all. Welcome to the Student brand. So that's enough. So this is about image formations of concave mirror. Thank you so much. Okay, so next one. Next one we are discussing about convex mirror. So convex mirror only two image formations are there. So pole, focus, center of curvature, pole, focus and center of curvature. Object is at infinity, image is forming at focus. So image will form at focus. Object is at infinity, image is forming at focus. Nature of the image is virtual erect. Virtual erect and diminished. Virtual erect and diminished. Virtual erect and diminished. And that is the first one. Coming to the second one. So object is placed here. One light I am taking like this. This is a pole. focus, center of curvature, object is placed between P and infinity, image is forming, object is placed between P and infinity, image will form between P and F. Nature of the image is virtual, erect and diminished. Virtual, erect and diminished. That is about convex mirror. So next one we will discuss about now we will discuss about power of so before that mirror formula will discuss. So 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object. That is nothing but minus v by u. Okay. So mirror formula 1 by f equal to okay, so here you can see 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object minus v by u. Okay, so this is about mirror formula and magnification. So magnification formula, magnification definition is so thank you so much for everybody, those who are supporting me, those who are encouraging me, those who are okay, so being with me right from starting. So I am happy for you all. So with my bottom of heart. So thank you everyone. So keep supporting, keep encouraging me. Definitely I will do my level best. So that's enough for today class. Thank you so much for joining and attending and listening. So this is our Shiva sir from Student Brand. So we'll see in the class every day at 9 p.m. We'll be having live class. Come and join to the class if you want classes. So you can contact to me through this number 98498 So if you want demo classes, not only physics, remaining subjects also maths, chemistry, biology, social, English. So there are most experienced faculty members are available, okay, in my team. Those who want to take classes, you can ping me through that number. So this is Shiva sir from Student the Brand. Thank you so much for joining and attending and listening my class and giving an opportunity to teach. So signing off. Namaste. Thank you. Yes, definitely I'll start.